Have you ever wondered what happens when you hit enter after typing a website address? How does your computer, in just a fraction of a second, connect to a server thousands of miles away? It feels like magic, but it's actually a brilliant system called TCP/IP. In today's digital world, we're constantly online streaming, gaming, and connecting with people everywhere. Behind all of this is the TCP/IP model, the foundation of the entire Internet. Today, we're going to break down exactly how it works, layer by layer, in a way that's easy to understand. Ready to see what's happening behind your screen? Let's get started. So, what exactly is TCP/IP? It stands for Transmission Control Protocol and Internet Protocol. Think of it as the ultimate rulebook for how data is packaged, sent, routed, and received across networks. It's made up of 4 distinct layers, and each one has a specific job. We have the network access layer, the internet layer, the transport layer, and finally, the application layer. These layers all work together seamlessly to make sure your data gets where it needs to go, whether it's to the person sitting next to you or to a server on the other side of the planet. Let's start at the very bottom, with the network access layer. This is the layer that's closest to the physical hardware, your Ethernet cables, your Wi-Fi router, and the network switches. Its main job is to take the digital data from your computer and get it onto the local network. It converts your data into something called frames and uses a unique physical address, known as a MAC address, to make sure the data goes to the correct device within your home or office network. So, if you're sending something to your printer, this layer ensures it doesn't accidentally go to your smart TV. It answers the question, how do I send data onto the physical network? Next up is the internet layer, and this is where the magic of global communication really happens. The star of this layer is the Internet Protocol, or IP. This is what makes the Internet the Internet. IP is responsible for taking your data, which is now broken into small pieces called packets, and sending it across the world. Each packet gets a destination IP address, like a mailing address for your data. Routers all over the Internet read this address and forward the packet along the best path toward its final destination. It's like a global postal service for digital information. This layer answers the question, how does my data find the right device anywhere in the world? Now we arrive at the transport layer. This layer is all about managing the communication between 2 applications. It's like the quality control manager of the Internet, and it offers 2 main options, TCP and UDP. TCP, or Transmission Control Protocol, is the reliable one. It establishes a connection with something called a 3-way handshake, makes sure all your data packets arrive in the correct order, and even resends any that get lost along the way. You use TCP for things like browsing websites, sending emails, and online banking where data integrity is crucial. On the other hand, we have UDP, or User Datagram Protocol. UDP is all about speed. It doesn't bother with handshakes or resending lost packets. It just sends the data and hopes for the best. This makes it perfect for live video streaming, online gaming, and voice calls, where a tiny bit of lost data is less noticeable than a laggy connection. Finally, we reach the top, the application layer. This is the layer we interact with directly every single day. When you open your web browser, check your email, or transfer a file, you're using protocols from this layer. Think of protocols like HTTP for websites, DNS for translating domain names into IP addresses, and SMTP for email. These protocols define the format and rules for how applications talk to each other over the network. This layer is what makes the Internet user-friendly and allows our favorite apps to function. So let's put it all together. You type google.com into your browser. First, the application layer uses DNS to find Google's IP address. Then, the transport layer uses TCP to set up a reliable connection with Google's server. The Internet layer packages your request into packets and routes them across the Internet. And the network access layer sends those packets out from your device onto your local network. Google's server sends the website data back, and the process reverses until the web page appears on your screen all in milliseconds. TCP/IP is the unsung hero of our modern world. It's universal, scalable to billions of devices, and incredibly powerful. Without it, the internet as we know it simply wouldn't exist. It's the backbone that connects us all. Thanks so much for watching. If you found this explanation helpful, please give this video a thumbs up, leave a comment with any questions, and don't forget to subscribe for more deep dives into the tech that powers our world. See you in the next one.